At Tokyo Medical and Dental University, we perform MRI ultrasound elastic fusion prostate biopsy in the operating room using the transperineal approach. We use Philips UroNav3.0 and BK-BK3000 ultrasound system. The ultrasound data are transferred to the UroNav3.0 via LAN cable connection, and all biopsy procedure steps are displayed on the UroNav3.0 screen. Endocavity biplane transducer is used, and UroNav3.0 Transperinial biopsy use only sagittal images. The cover for the ultrasound probe can be a condom that is used for a normal transrectal ultrasound probe, but we use a Civico latex-free endocavity balloon. The latex-free endocavity balloon covers the endocavity transducer during the procedure, inflating and deflating the balloon with normal saline during biopsy procedure assists positioning the prostate within the grid coverage. The UroNav 3.0 supports both the grid plate and the freehand transperineal workflow. We are currently using grid plate transperineal workflow that is approved in Japan. First, a stepper arm clamps to tables with support bar, then slide the stepper in the arm mount and close the lever. After that, slide the transducer, close the clamp and tighten thumb screw. The stepper is dialed to allow for overall front and rear position adjustment. The ultrasound probe is manually adjusted for rotation. Fine adjustment of the grid position of the template at puncture is performed using levers on the left and right sides of the lower face of the template. These levers are located on the left and right sides of the template and allow for easy adjustment of the angle of the template. Real-time navigation with UroNav uses a magnetically guided sensor. First, the field generator is set in the front of the patient's pelvis. This field generator creates a magnetic field space using a weak magnetic field around the pelvis. The magnetic sensor clips are then attached to the stepper for real-time tracking of the position of the ultrasound probe and grid. Attach the magnetic sensor clips to the side of the stepper and the side of the grid respectively. I liken it to the GPS function using car navigation systems, where the satellites for GPS is the field generator. The equivalent of the vehicle being located will be the magnetic sensor clip that indicates the position of the ultrasound and the template. After driving the device, push the grid plate down and tighten thumb screws. The grid is a disposable item. The UroNav biopsy begins with T2 weighted images analysis. The contour of the prostate and the contour of the biopsy target are made on dedicated image analysis workstation, DynaCAD. These data are registered in UroNav prior to the biopsy. The pre-registered data are displayed in the right column of the screen. Select the data of the patient to be biopsied from among them and load it. On the T2 weighted image, information about the prostate and biopsy target is displayed. In the lower right corner, a 3D image of the prostate and biopsy target is shown. Next, follow the navigation to select the biopsy needle, grid, and ultrasound probe to be used in the biopsy. In the upper right corner, you will see the positional information of the ultrasound probe and template being tracked. The next step is to create a 3D model of the prostate using ultrasound images by rotating the ultrasound probe in sagittal view by 180 degrees to scan the entire prostate. The system then reformat axial, sagittal, and coronal images of the scanned ultrasound images. By specifying the ventral, dorsal, right and left sides, base and apex of the prostate on these three ultrasound sections, a 3D image is automatically constructed. Then, fine-tune manually to create a 3D model for use in the biopsy. The next step is elastic fusion. the prostate contour information generated from the MRI image showing red and that from the ultrasound image showing green are aligned and elastically fused. After this process, the ultrasound image shows the area corresponding to the biopsy target specified on the MRI image. This completes the pre-biopsy preparation. The biopsy puncture itself is very easy to perform. In the upper left corner, the outline of the prostate and the biopsy target are shown in real time on the ultrasound image. A red dotted line guides the user to the position where the center of the target is. In the lower right corner, the grid position, the position of the prostate, and targets are shown in real time. The positional information of the punctured site is recorded. After the biopsy, a detailed analysis of the site taken in the biopsy can be performed. For a lineage biopsy, the information in the lower right corner is still used to select a template grid corresponding to the location to be sampled, and the puncture is performed. Once the biopsy is complete, target information and the area where the biopsy was performed are displayed as a 3D image. You will be able to see that the target was punctured accurately and that the biopsy was performed in an even lineage.